Good morning, everyone. So, in this class, we are going to develop some ideas on the ray optics. We all know that ray optics is one of the important chapters for the students who are preparing for NEET or JEE examination. So, in this class, right, in this particular video, right, we are going to focus on plane mirrors and its function, and side by side, after teaching the concepts, we can also work out the problems also on plane mirrors. Okay, first I will start with the ray optics. See, these ray optics is fully developed by the Newton himself. This method is actually called as geometrical method also. In ray optics, the light rays are treated as a kind of rays or beams. Rays are nothing but, you can imagine, as per the Newton statement, the light behave as a stream of energy propagated along a straight line. So that along the direction we are imaginally drawn a line. That imaginary line is called as ray. So any bundle of rays are literally called as beams. So for example, if this is a ray, right, it's called as beam. Any bundle of rays are called as beams. Based on these rays and beams only, we are going to discuss all the reflection principles. So kindly make a clear understanding on this. So we can start with the beams of light now. Okay, these beams of light can be classified into three types. The one is called as parallel beam of light. Parallel beam of light in the sense, uh, see, for example, consider this is the sun, right? This is the earth. The distance between the sun and the earth is enormous. From the surface of the sun, the light rays are having a diverging nature, right? But if you look very closely into the light ray that is passing through the earth surface, or that is intercepted by the earth surface, these light rays are nearly parallel, right? So uh, I can say that then any ray of lights, okay, if they are parallel to each other, those bundle is called as parallel beams of light. It's called as parallel beams of light because these light rays are parallel to each other locally at least. Similarly, look into this. If you are being very closer to the sun, then these light rays are not parallel to each other. They are having a diverging nature. So these light rays are called as a divergent beam. Similarly, uh, you can consider this example also. If you are having a convex lens, okay, I will talk about the lens in more elaborate way over the course of time. Right now, understand this. Convex lens is nothing but it's a kind of transparent glass which can converge the light ray that is falling onto it. So if any light rays are falling on this convex lens, it has a tendency to converge that light ray into a point. So if you focus on these light rays, this part of the light rays, you can very clearly sense that these light rays are having the tendency to converge at a point. So that's why these beams are called as convergent beam. Convergent beam. Okay. Once if you got a very clear idea about the beams, in terms of these rays and beams, we can understand the reflection principles in more detailed way. I will tell you the reflection principle first. Consider a plane mirror over here, right? If you shed a kind of light on this plane mirror, okay, but at an angle to a normal. So I hope that by the word normal, we are indicating any line that is perpendicular to the plane mirror surface is called as normal line. So at this point, at this location, I have drawn a normal line. Okay. So this I have shed a light ray on this plane mirror. Okay, it's a plane mirror. These incoming light rays are making a certain angle to the normal line. So law of reflection tells us that if this incident ray is making some I angle with respect to the normal, the reflected ray will also make the same angle. So this principle is called as laws of reflection. Actually, in laws of reflection, we'll be having the two statement. The one statement is this, another statement is this incident ray and reflected ray and normal line. All the three lines can be confined to a same plane. It's a second statement of law of reflections. Together with these two statements, we can complete the laws of reflection. And regardless of the mirror types, it could be a plane mirror or spherical mirror or a parabolic mirror, whatever could be the shapes and sizes of the mirrors, all the mirrors will obey these laws of reflection. In fact, based on the laws of reflections only, all the reflective surfaces, all the mirrors are working. We can see how this is the case. Before going into it, I will tell you how the image formation is happening. Okay, so for that we can consider plane mirror once again. Over here, it's a plane mirror. It's a plane mirror. It's a mirror world. It's a real world. Mirror world in the sense, if you look into the plane mirror, right, you can see yourself, right, and you can also sense that that image seems to be lying at certain depth from the mirror surface, right. So that world I called as a mirror world. So it's a real world, it's a mirror world. If I placed any object over here, right, in a real world, so since I am placing the objects in the real world, so and we are talking about the real objects, so I can call this as a real objects. We are also having a virtual object also. I will discuss about that later. For timing, we can consider real objects alone now. So it's a real objects. We are going to see and where and at what location the images of these real objects will be formed by the plane mirror. It's what we are going to find out now. Okay. By simply applying the laws of reflection itself, we can able to get the image locations and image nature also. So first we can consider, see any objects, right. If you look around yourself, you can see so many objects. You are seeing all those objects because those objects are reflecting some lights that is falling on it, and those objects themselves are not emitting any visible light more significantly, but they are simply reflecting the light that is falling on them. It could originally it could be the sunlight or any kind of light that was that would be created from the artificial light source that may originally fall on those objects, and those objects are having the tendency to reflect off the partially fraction of the energy that is falling onto it. So our eyes sensing that reflected light, so that's how the images of those objects are formed in our retina, right. So consider this is the real objects, and from these real objects in all the direction a kind of light will be reflected off. To get the image location, we need just two light rays. Any two light rays, with those two light rays we can able to pinpoint the locations of the image clearly. Consider one light ray like this. This light ray is approaching the plane mirror in this way. At this point of incident, if I draw the normal is going to like this. Okay, you can very clearly see one thing here. The incident ray is making the zero angle of incidence. So from the laws of reflection statement, we can very clearly say that angle of reflection should be equal to the angle of reflections. Angle of incidence is equal to angle of reflection. So in that case, if the incoming light ray is making the zero angle of incidence, the reflected ray is also going to make the same zero angle of reflection. So this is going to be the reflected ray's path. Okay. Now consider one more light ray also from the same real objects, but this light ray we can consider in some arbitrary angle to the plane mirror surface. Okay. So at this point of incident, you can draw one more time normal line. So it's a normal line. So you can see very clearly here. Here the incoming light is making a certain angle to the normal line. Let me call that angle as I. Okay. And from the law of reflection, we can very clearly tell that the reflected light ray is also going to have the same angle to the same normal line. So it's going to be the reflected line, right? Reflected light ray. As far as the external observer is concerned, right? So these two light rays are reflected light rays. It's a reflected ray 1 and reflected ray 2. So as far as the external world is concerned, right, these two reflected rays are coming from kind of image of the object. So which means if we backwardly extend this reflected light rays, they seems to be meeting somewhere into the plane mirror. So that's where the images will be formed. I had see from the figure you can very clearly sense that from the mirror, right, from the mirror, whatever the distance the real object is making, the same distance will be made by the images also. So, if distance is 10 centimeter, this distance is also 10 centimeters, which means object to mirror distance will always be equal to the image to object, image to mirror. For a plane mirror, this will be the case all the time. So, I think it's not very complicated for you to understand this, because you might have already observed this in day-to-day life. If you look yourself into the plane mirror, whatever the distance you are having, whatever the distance you are making with the plane mirror, the same distance will be made by the images of yourself from the plane mirror also. Okay, so it's one of the important thing you should be very familiar with. And once if you got this idea very clearly, you can understand this fact also. So, for the plane mirrors, object to mirror distance is equal to mirror to image distance. If you call this distance as a u, if you call this distance as v, so it's so clear that u equal to v magnitude wise. Okay, and if you differentiate this parameters with respect to the time, you can also get the speed relationship between the object and the image also. For example, if you differentiate this u with respect to the time, you will be getting a du by dt. Similarly, if you differentiate the v with respect to the time, you will be getting a dv by dt. Du by dt is nothing but object speed, and it is nothing but image speed. It is so clear then, object speed is equal to the image speed for plane mirrors. If any object is approaching the plane mirror at 20 meter by second, the image will also approach the plane mirror the same 20 meter by second speed. Is it clear? So, with respect to the object, right, the image may seems to be approaching it at 40 meter by second, because I hope that by this time you are already familiar with the relative velocity concepts. So, if the object is looking into the image, that image may seems to be approaching the object at 40 meter by second, which includes the reverse velocity of the object also. So, with respect to the object, right, the image may approaches it at 40 meter by second speed. It's so clear. And once if you got this idea so clearly, right, then we can proceed further. Now consider this case. We have an object over here and the image over here. It's an object, it's an image. Both are located at the equal distance from the plane mirror, right? And now, instead of moving the object or image, so what would happen if you are moving the mirror itself? Okay, if you are displacing the mirror toward the objects by x distance, what will happen? So, if the mirror got displaced over here, right, now the distance between the mirror and the object got shrinked, right, by the amount of x. Similarly, the image will be displaced by 2x distance. So, if I am moving the mirror by x distance, the image will move by 2x distance. Okay, now consider this case. If you are having the two plane mirrors, if I am placing that at a certain angle to each other, right, and in between these two plane mirrors, if I place a object over here, right, how many number of images will be formed? If that's a task to find out, we can able to get that by using this formula. Imagine it's a mirror 1, it's a mirror 2. So, these two mirrors are making the angle of theta between them. So, between these two plane mirrors, I placed a object. So, the task is to find out how many number of images it will be making. Okay. To get the answer to it, right, we should find out this, because we know that for a circle, the totally we are having a 360 degree, right. So, if you divide 360 by the theta, you will be having something, right. If that quantity is even, the number of image formed can be figured out by using this formula simply. For example, if this theta is 60 degree, right, then the 360 by theta, your task is you should find out this quantity first. 360 by theta is equal to 6. So 6 is an even number, right? If 6 is an even number, the number of image formed is equal to 360 by 60 minus 1, which is 6 minus 1, 5. So number of image formed is going to be a 5 in that case. But what will be the case if the 360 by theta value is odd means? Imagine if the theta is 72 now, okay, if you try to calculate the 360 by theta, and obviously that value is going to be an odd number, right? If the 360 by theta value is odd, then you have to look for the symmetry conditions. So you have to look for the symmetry conditions. If the object is placed exactly on the angle bisector, okay, if the object is placed exactly on the angle bisector, and again you can make use of the same formula once again. What are the formula you used for even conditions? When the 360 by theta value is even, the same formula can be utilized for odd conditions also if the objects are placed symmetrically, which means if the objects are placed exactly on the angle bisector, right? So the number of image formed can be figured out by using the same formula which we discussed before. So here also you will be getting a 360 by 72 minus 1, so which is 5 minus 1, 4. So total number of image formed is going to be a 4 then. But if the objects are not placed symmetrically, right? So if the objects are placed asymmetrically, let's imagine that it's angle bisector, the angle is theta 72, but object is not placed exactly on the angle bisector, it is placed like this. You can very clearly see that here the objects are not clearly placed on the angle bisector, it's angle bisector, right? Angle bisector. So if the objects are placed asymmetrically like this, then number of image formed can be calculated by using this formula simply, 360 by theta. So by using this formula you can simply get the total number of image formed. So you will be getting a 360 by 72, which is 5. So the total number of image formed is 5. Okay. And if you are placing any parallel plane mirrors, okay, in between these two parallel plane mirrors, if you are placing a kind of objects, then the total number of image formed is equal to 360 by 0, 1 by 0 is equal to infinite. So the infinite number of image will be formed in that case. I think that you might have sensed this in the barber shop, right? If you have visited a barber shop, and there they will be placing one mirror on the front side and another mirror on the back side, and you will be sitting between them, right? So and there you can see the infinite versions of yourself in the mirror. So you can able to get all those ideas from these formulas. Okay. And there are some few more important points I just want to discuss regarding the plane mirror. Okay. Consider this is the plane mirror, right? I will discuss all the behavior of the plane mirrors now. Okay, side by side, one by one. So if object is placed at u distance from the plane mirror, the image will also be formed at the same u distance into the plane mirror. Object, image. If the object is approaching the plane mirror with the u speed, the image will also, if the object is approaching the plane mirror with the v speed, the image will also approach the plane mirror with the same v speed. So the relative velocity between the object and image is 2v. Similarly, if I am moving the mirror towards the objects, the image seems to be moving towards the mirror at 2v speed. It's also we discussed before, right? Apart from that, instead of placing point sized objects, if you are placing real world objects like which are having some dimensions. So if this object is having a height of h, o, height of the object, the image of this object will also be having the same height exactly. There will be no difference, there will be no reduction in size or whatever. Okay. the image size. So, it is so clear h naught is equal to hi for plane mirror. The size of the image is going to be the same as the size of the object, and similarly the distance between the object and image is going to be the same as the distance between the image and mirror. So, the distance between the object and mirror is going to be the same as the distance between the image and mirror. Okay. Now consider this case. So, what's minimum size of the plane mirror we require to see the full images of a person? They may ask a question like this. For that also we can try to find out the answers now. Let's say that this is the person we have. Okay, this is the person we have. I have represented the person as a kind of straight line, okay, kind of approximation. This is where the person's eye is located. It's eye. It's eye of the person, okay, and it's a plane mirror we have. The question is about what minimum size of the plane mirror we require so that a person can see the full images of himself onto it. It's a thing we have to find out now. Okay, imagine in the person's already leg பார்க்கறாருன்னு வெச்சுக்கோங்க, right? So leg la oru light ray, consider this light ray. This light ray is coming from the leg. After getting reflected, it should reach his eyes, right? Then only he can able to see his leg clearly. Similarly, you can consider one more light ray from the head. Okay, from the top tip of the person's head, you can imagine one more light ray. That light ray is coming and it is falling onto the plane mirror. It got reflected back. It is entering into his eyes again. From the laws of reflection, we can very clearly tell that if this is the normal, right? If this angle is I1, this angle is also I1, right? If this angle is I2, this angle is also I2. It's so clear. Then from the logic, you can very clearly infer that if this distance is x, obviously this distance should be also x, correct? Similarly, if distance is y, this distance also should be y. So the total person's height is equal to 2x plus 2y. It's the total person's height of the person. Whereas the height of the plane mirror, we need to see the images of the images of the observer fully is equal to, you can see here the height of the plane mirror is equal to what? It's simply x plus y. Is it right? So height of the plane mirror, is equal to simply x plus y. So it is so clearly done. Height of the person should be height of the person is twice times of the height of the mirror. It's so clear. So height of the mirror should be equal to 1/2 times of the height of the person. So if the person's height is 6 feet and if he wants to see his image fully onto the plane mirror, for that he need the mirror which should have the height of 3 feet. It's what we proved through these ideas. Okay. Okay, now consider this idea also. If we have the two plane mirrors, the angle between them is theta. Now consider a incident light ray. Okay, let's say that this is the incident light ray. It is approaching it's a mirror 1, it's a mirror 2. So this incident ray is approaching the mirror 1 at a certain angle to the normal. Let me call that angle say alpha. From the law of reflection, we can very clearly tell that the reflected ray is also going to make the same angle alpha. Is it right? So again, this reflected ray is falling onto the plane mirror 2, and there if you try to draw the normal line is going to look like this. Let's say that this ray is making some beta angle with the normal line over there. So again the reflected ray is going to make the same beta angle one more time. So it's going to be a finally emerging light. Okay, it's going to be a finally emerging light. The question is about what will be the total deviation angle. Okay, the total deviation angle produced by the reflections at two mirrors inclined to each other at angle theta. We can able to calculate that now. So deviation angle is nothing but If there was no mirror, this light ray might have travelled in this way, right? Because of the presence of these two plane mirrors, it is finally moving along this way. So its path got changed by this much. So this angle is called as deviation angle. Okay, how can we get this angle first? I will tell you the way to calculate that. First, you can see if this angle is alpha, this angle also should be alpha, correct? And this should be what? This angle should be a 90 minus alpha. If this angle is 90 minus alpha, right? This angle also should be a 90 minus alpha. It is so easy to visualize because it is a 90 degree, it is a 90 degree. So if this angle is alpha, this should be 90 minus alpha. So I can very clearly tell that these angles are equal to 90 minus alpha plus 90 minus alpha. Okay. So these angles are 90 minus alpha and 90 minus alpha, and this light ray is falling over this plane mirror too, and its angle got deviated one more time by this much. It is so clear that this angle is equal to, it is a 90 minus beta, okay. So it is also 90 minus beta. I will clearly illustrate this. Look into it clearly. I will draw it one more time. This angle is beta, right? Okay, let it be. See, originally this is the incoming light ray, right? This incoming light ray is falling onto the plane mirror 1, and its path got deviated by 90 minus alpha plus 90 minus alpha, and it's again falling onto the plane mirror 2. So originally its path is going to be like this, but its path got changed by certain amount. So we can able to get the deviation angle 2 by using this formula. So it's if this is beta, right? So this should be a 90 minus beta, and it is also 90 minus beta. So if I add this 90 minus beta, I will be getting the deviation angle 2 also. The total deviation angle is nothing but 90 minus alpha plus 90 minus alpha plus 90 minus beta plus 90 minus beta equal to the total deviation angle. I can say that it is a 360 minus 2 alpha minus 2 beta, which is equal to the total deviation angle. I can able to write this. Consider this triangle. We can very clearly say that (90 minus alpha, 90 minus beta so the sum of the interior angle of the triangle should be equal to a 180. We have learned that, right? So 180 minus alpha minus beta plus theta equal to 180. I can very clearly say that 180 will be cancelled off, theta equal to alpha plus beta. So if I substitute that over here, I will be getting what? The total deviation angle is equal to 360 minus 2 theta. It is going to be the answer then. Okay, now we can work out some problems based on this laws of reflections and the plane mirrors. Okay, look into the first question now. The two plane mirrors inclined to each other at an angle of 72. What is the number of image formed? We already discussed that, right? So we have the two plane mirrors. The angle between them is 72. Between these two plane mirrors, we placed the objects. They have not spoken anything about the symmetric conditions of the objects. So we can orbitally assume that by nature, if they have not spoken anything about the position of the object, we can by nature we can assume we have placed the object exactly at the angle bisector. Okay. So now imagine the number of image formed can be calculated by using this formula 360 by theta. Calculate this first, 360 by 72, so it's a 5. So number of image formed should be equal to, see if the 360 by theta value is add, so the total number of image formed is equal to what? 360 by theta minus 1, right? So 5 minus 1 is equal to 4. The total number of image formed is going to be a 4. It should be the answer. But since we didn't have this 4 as the answers in the options, then maybe it could be possible that this object may not be placed exactly on the angle bisector, it could be placed somewhere. So if the objects are placed asymmetrically, then the number of image formed can be calculated by using this formula 360 by theta itself. So you got what? 360 by 72 equal to 5. The total number of image formed should be equal to 5. So 5 should be the answer then. This should be the answer. Okay. Now look at the second question. If mirrors are kept at 60 degree to each other, the number of image formed, again use the same formula 360 by theta. Try to calculate this quantity first. 360 by 60, you got a 6. 6 is an even number. Okay. If the 6 is an even number, right? If the 360 by theta value is the even number, the number of image formed can be calculated by using this formula simply. 6 minus 1, 5. So 5 should be the answer then. Okay. And this thing, right, look into the fourth question, we solve this now, right, we solve this just now only. Okay, so answer is what? 360 minus 2 theta, it should be the answer. And we solve this thing also now. A tall man of height 6 feet wants to see his full image, then record minimum length of the mirror will be equal to what? It should be 3 feet. Now only we derived the expression for that, right? Height of the mirror should be equal to height of the persons by 2. So height of the person is 6 feet. So 6 feet by 2 is equal to 3 feet. So height of the mirror should be equal to 3 feet. This should be answer. Okay, now look into this question, 12th question. We have the two plane mirrors. Okay, they are placed parallel to each other. They are placed in such a way that they are parallel to each other. The gap between them is 0.2 meter. The length of the mirrors are 2 root 3 meter. Okay. The question is about, see, one light ray is approaching the plane mirror A at a certain angle. The maximum number of times the ray undergoes the reflection before it emerges out. They are asking about the number of times it undergoes the reflection phenomena. Okay, it's what we have to calculate now. So imagine if this is the incident ray, right? The reflected ray is going to make the same angle with the normal 30. So again at this location, if you draw the normal, okay, this incident ray is going to make the same 30 degree with that normal also. So again the ray will get reflected like this. So the reflected ray is also going to make the same 30 degree. So it, in such a way it will undergoes the multiple reflection before it finally emerges out. Okay, the task is to find out how many number of times it will undergoes the reflection phenomena, right? Okay, imagine, consider this length of the light ray as a L. Okay, it is so clear that the projections of this L over this line is equal to what? L cos 30. We know that L cos 30 is equal to 0.2 meter. They have given that in the question itself. We know that L cos 30 value is, I suppose that it's a root 3 by 2. So L is equal to 0.2 into 2 by root 3. We got L now, right? Now imagine, we know this distance also, it's a 2 root 3, and we know if you consider this part of the reflection as a single reflection, okay, the projections of this L over this line is equal to what? L sin 30, okay. So L sin 30, L sin 30, so in this way, if it undergoes the n reflection, the total length, okay, is equal to what? N L sin 30. Yes, if it undergoes the n number of times, n times reflection, if it undergoes n times reflection, then each time it will covers L sin 30 horizontal distance. Sorry, L sin 30 horizontal distance. So the total horizontal distance covered by that light ray during its n times reflection is equal to NL sin 30, and its value is given in the question itself, 2 root 3. So n, in the place of L you can substitute 0.2 into 2 by root 3, and sin 30 is nothing but 1 by 2. So 2 root 3. These two will get cancelled off. I can simplify that as n equal to 2 root 3 into root 3 by 0.2. What I got? I got a 2 into 3 by 0.2. 6 by 0.2. 0.2 can be written as 2 by 10. I got what? 60 by 2, it's a 30. So number of times it may undergoes the reflection phenomena is equal to 30 times. So these are some ideas you should be very familiar with. Now we can also work out some previous year questions also. Look into this first question. This question they asked in NEET 2013. So consider two plane mirrors. They are making the angle of inclination of 70 degree. A ray incident on one mirror, okay, at an angle theta. After reflection, falls on second mirror, okay. After reflection, it is falling on the second mirror, and is reflected from there parallel to the plane, parallel to the first mirror. So after getting reflected, it became parallel to the mirror one. So it's a finally emerging ray, okay. At this point, if you draw the normal is going to look like this. This angle is beta and beta, say theta theta. We have already seen the relationship between this theta and beta and deviation angle, right? So the total deviation angle, we can able to calculate that as this. It's a deviation angle, right? We can calculate that deviation angle. We know the relationship of that. Delta is equal to 360 minus 2 theta. So 360 minus 2 theta. In that formula, we call the theta as angle between the two plane mirrors. So here the theta means it's a 70 degree. So 2 into 70. What you got? 360 minus 140. Value is coming very closer to what? 220. So deviation angle is 220. If the deviation angle is 220, theta equal to alpha plus beta. Alpha is beta plus beta. So deviation angle is 220. So this angle is 220 degree. Yes, it's the original path of the light ray. It's finally emerging out light ray direction. The angle between them is deviation angle. So it's a 220. So if you subtract 180 out of this 220, right? So if this is the 180, right? So if you subtract 180 out of this 220, you'll be getting the remaining angle. So this angle is 220 minus 180. I'll be getting the value very closer to what? 20, 40 degree. If this angle is 40, then this should be what? 50 degree. If this angle is 50, then alternate angles are equal. The theta is also 50 degree. Then the theta should be a 50 degree angle. So we got the answer. Okay, now look at the 7th question.